In 1977, two spacecraft left Earth on a mission that few imagined would become one of the greatest achievements in the history of exploration. Their names were Voyager 1 and Voyager 2. Built to study the giant planets of our solar system, they were expected to operate for only a few years before their mission came to an end. Instead, they changed humanity's understanding of the cosmos forever. Their incredible journey was made possible by a rare planetary alignment that occurs only once every 176 years. Jupiter, Saturn, Uranus, and Neptune were positioned so that a single spacecraft could use each planet's gravity as a natural slingshot, gaining speed while conserving fuel. This opportunity became known as the Grand Tour, allowing the Voyagers to travel farther than any previous mission. Voyager 1 reached Jupiter in 1979 and immediately transformed scientists' view of the giant planet. Instead of finding a quiet gas giant, the spacecraft revealed a world of violent storms, powerful magnetic fields, intense radiation, and a complex family of moons unlike anything previously observed. Among its greatest discoveries was Io. Before Voyager arrived, scientists believed moons in the outer solar system were mostly frozen and inactive. But Voyager captured the first direct evidence of active volcanoes erupting on another world. Massive plumes of material rose hundreds of kilometers above Io's surface, proving that moons could be geologically alive. The discovery forced scientists to rethink how planetary bodies evolve. Voyager also examined Europa, another of Jupiter's fascinating moons. Its icy surface was covered with long cracks and surprisingly few impact craters, suggesting that something beneath the ice had reshaped the surface over time. These observations provided the first strong clues that a vast ocean of liquid water might exist beneath Europa's frozen crust. Today, Europa is considered one of the most promising places in the solar system in the search for environments that could support microbial life. In 1980, Voyager 1 continued to Saturn. From Earth, Saturn's rings appeared smooth and elegant. Up close, Voyager revealed an astonishingly complex system made of thousands of narrow ringlets, gaps, waves, and structures shaped by gravity and tiny moons orbiting within them. The spacecraft also discovered new satellites and studied Saturn's atmosphere in remarkable detail. Its most important target, however, was Titan. Titan possessed a dense atmosphere unlike any other moon known at the time. Thick layers of nitrogen and hydrocarbon compounds completely hid its surface from view. Although Voyager couldn't see through Titan's orange haze, its instruments showed that this moon possessed an incredibly rich chemical environment. Later missions would confirm that Titan contains lakes, rivers, rainfall, and even weather, but instead of water, these features are made primarily of liquid methane and ethane. The close flyby of Titan dramatically changed Voyager 1's future. Rather than continuing toward Uranus and Neptune like Voyager 2, Saturn's gravity redirected Voyager 1 upward and out of the plane of the solar system. From that moment forward, Voyager 1 became humanity's first true interstellar explorer. Its planetary mission had ended. A much greater journey had just begun. For more than 3 decades after leaving Saturn, Voyager 1 traveled steadily toward the outer edge of the Sun's influence. Then, on the 25th of August 2012, history was made. Its instruments detected a dramatic change in the surrounding environment. Solar particles rapidly decreased while high-energy cosmic rays arriving from deep within the Milky Way became much more abundant. Scientists concluded that Voyager had crossed the Heliopause, the outer boundary of the heliosphere, the enormous bubble created by the solar wind. Beyond this point, Voyager entered interstellar space. Contrary to popular belief, the region between stars is not completely empty. Voyager's plasma wave instrument detected extremely thin clouds of charged particles drifting through the galaxy. By measuring tiny plasma vibrations, scientists could estimate the density of interstellar material surrounding the spacecraft. Its magnetometer also revealed that magnetic fields continue far beyond the solar system, connecting our local region to the much larger structure of the Milky Way. These discoveries showed that interstellar space is a dynamic environment shaped by magnetic forces, energetic particles, and ancient stellar events. What makes Voyager's accomplishments even more extraordinary is its age. Designed with technology from the early 1970s, the spacecraft contains only a tiny fraction of the computing power found in modern electronic devices. Its systems are powered by radioisotope thermoelectric generators that convert heat released by slowly decaying plutonium-238 into electricity. As the available power gradually decreases each year, engineers carefully switch off non-essential instruments to extend the spacecraft's operational life. Despite these limitations, Voyager continues communicating across more than 24 billion kilometers of space. In late 2023, however, that communication was suddenly threatened. The spacecraft began transmitting corrupted data that engineers could not immediately understand. Because radio signals require almost an entire day to reach Voyager, and another day for a reply, every troubleshooting attempt required extraordinary patience. After months of careful investigation, engineers traced the problem to corrupted memory inside the flight data system. Instead of ending the mission, they developed an ingenious solution. By relocating software instructions into a healthy section of onboard memory, they successfully restored the spacecraft's ability to transmit readable engineering and scientific data. In 2024, Voyager resumed sending valuable observations from interstellar space. Nearly 50 years after launch, it continues expanding humanity's knowledge of the galaxy. Attached to Voyager is perhaps its most famous feature, the Golden Record. This gold-plated disc carries music, natural sounds, greetings in dozens of languages, photographs, and scientific information representing life on Earth. Whether another civilization ever discovers it is impossible to know. But the record was never simply a message to others. It is also a message about ourselves. It reflects humanity's curiosity, creativity, and desire to explore beyond the horizon. Long after its instruments finally fall silent, Voyager 1 will continue drifting among the stars for thousands of years, carrying a small piece of Earth into the vastness of our galaxy. It remains one of humanity's greatest achievements, a tiny spacecraft proving that even the longest journeys begin with a single launch toward the unknown.